Welcome to OOTOT-TV, the out-of-the-office investigation from the past into the future of marine navigation and autopilot technology. This time, we're discussing the requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation. Now, that is a mouthful, I know, but what we're really talking about today is creating the master blueprint. This is the single most important document that lays the groundwork for how mariners are going to safely find their way through everything, from the busiest, most chaotic harbors to the vast, quiet, and sometimes terrifying expanses of the open ocean.
That's exactly right, Skipper. And, this image really cuts to the core of why this whole concept, this blueprint, is just so unbelievably important. When you're out there on the open ocean, the sky is turning a nasty shade of gray, and the nearest land is 1,000 miles away, well, let's just say making it up as you go is not an option. A navigator's life, their crew, the ship, the cargo, it all comes down to the absolute certainty that the systems will work exactly as they were designed. Success out there isn't about improvisation. It's about meticulous, exhaustive, and life-saving specification. Absolutely. So, to get to that flawless system, we have to start with that perfect blueprint. And in this explainer, that's exactly what we're going to do. We're going to build that requirement specification from the ground up, looking at 5 absolutely critical areas. First, we'll talk about the master plan itself, what a specification even is. Then, we'll zoom right in on the most important person in this entire equation, the mariner. After that, we'll get our hands dirty with the technology underneath it all, navigate the incredibly complex world of international rules and risks, and finally, we'll see how it all comes together in the command center, the fully integrated bridge.
Okay, let's get into it. The very first thing we need to wrap our heads around is this core concept, the Requirements Specification, or the RS for short. I really want you to think of it like an architect's complete set of plans for a skyscraper. Before anyone pours a foundation or orders a single steel beam, those plans lay out in crystal clear, unambiguous detail exactly what the building must do, how strong it has to be, and all the laws and codes it must follow. The RS does the exact same thing for a navigation tool.
You've hit the nail on the head, Skipper. And any good, robust requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation has to be clearly defined in a step-by-step manner to meet 3 primary categories. You can think of them as the 3 massive pillars holding the whole structure up. First, you've got audience needs. What does the actual person on the bridge need to do their job safely and get home? Second, the technical requirements. What guts, what hardware, what software do we need to build to make that happen? And third, safety regulations and restrictions for travel. This is the whole universe of laws and standards that keep the seas safe. You see, Skipper, if any one of these pillars is shaky, the whole thing comes crashing down.
So let's start with that first pillar, because you could argue it's the most important one of all, designing for the mariner. It's a simple truth, really. You can have the most brilliant technology, the most elegant engineering in the world, but if it doesn't actually help the person on the bridge, if it's confusing or clunky or just doesn't do what they need it to do in a storm, then it's a failure, plain and simple. This is all about the human at the center of the machine.
And this leads us right to the big question, the one you have to ask before you do anything else. So, what features are required for marine navigation and piloting systems for both inshore and offshore global navigation to provide a modern and high-quality experience for the user? We're way past just drawing a line on a map to get from A to B. We're talking about total situational awareness, about making the ship more efficient, and, maybe most importantly, about reducing the stress and the mental workload on the crew who stand watch, day and night.
And the answer to that question is, well, it's complicated, because there's no single user. The mariner navigating a busy port, like you see on the left, that's a world of constant radio chatter, ferries crossing your bow, shifting currents. It's organized chaos. Their needs are completely different from the crew on that vessel on the right, steaming across an empty ocean for 2 weeks where long-range weather routing and fuel efficiency are king. It's why the requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation vary by region, size and type of vessel, and local laws and situations, weather, events, and tradition. What a tanker needs is not what a tugboat needs.
So, given all that variety, what are some of the universal must-have features? Well, at the heart of any modern bridge is the ECDIS, the Electronic Chart Display and Information System. And believe me, it is so much more than just a fancy GPS. It's an active partner in safety. The software doesn't just show you where you're going, it constantly checks your route against the charted depths and will scream at you if you're about to run aground.
It pulls in data from your radar and shows you other ships right there on the chart, telling you if you're on a collision course. And it has these life-saving functions, like a big red man overboard button you can hit in a panic, and it instantly marks the spot and tells you how to turn around and get back there. It's all about delivering the right information right now.
Okay, so we know what the mariner needs the system to do. Now we get to pull back the curtain and look at our second pillar, the technology that actually brings all those features to life. We're talking about the guts of the machine now, the sensors, the processors, the radios, all of it.
You're listening to OOTOTV with research by author Paul Bulow.
Right, and that brings us to our next mandatory question for building this blueprint. We have to ask, what are key technical elements for implementation, requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation integrated into the bridge navigation station for both small and large vessels? We're basically shifting gears now. We've talked about the what, all those cool user features. Now it's time to talk about the how, the nuts and bolts that make it work, whether you're on a 30-foot fishing boat or a 1,000-foot container ship.
And the absolute foundation, the bedrock that everything else is built on, is the Global Positioning System, GPS. I mean, it is just a breathtaking piece of engineering when you stop and think about it. You have this whole constellation of satellites, each one zipping around the Earth with an atomic clock on board that is accurate to within billionths of a second. They're all constantly beaming down a simple message. Here's who I am, here's where I am, and here's the exact time. Your little receiver on the ship's mast just listens for a few of those signals, does some very clever math based on how long each signal took to arrive, and bingo, it knows its position on the face of the planet down to a few feet. It's magic! So that's our position. The next critical piece of the puzzle is speed. And for that, we have the Doppler speed log. It's a clever device. It shoots beams of sound down at the seabed, and then it listens for the echo. And just like the sound of an ambulance siren changing pitch as it passes you, the frequency of that returning echo shifts based on your speed. That gives you your speed over the ground with incredible precision. But here's the really cool part. It can also bounce sound off of tiny particles in the water itself to calculate your speed through the water. And knowing the difference between those two numbers instantly tells you how fast the current is moving and in what direction. That is vital information. Okay, so we've got position and we've got speed. But in today's world, a navigation system can't just be a lonely box with a couple of sensors. It has to be connected, deeply connected. Which brings us to our third and maybe the most important technical question. Can users connect to both integrated sensors and connect to databases through Starlink satellite and VHF analog and digital transmission, as well as other radio frequencies that deliver real-time weather and location navigation data systems to integrate and use library data to relay time update new geographic region and new weather data from marine navigation and piloting tool for both inshore and offshore global navigation? The answer to that long question has to be a short, simple, and resounding yes. That connectivity is everything.
This system has to be the ultimate data hub, the requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation, incorporates existing databases of charts, maps, noting passages, channels, obstacles, depths, traffic, weather, and updates maps and course in real time using satellite and real-time data from the boat sensors of GPS, depth, speed, currents, fuel, and desired course and ETA. It's all about fusion. It takes data from the ship's own sensors and seamlessly blends it with data coming from the outside world. A perfect example is the Automatic Identification System, AIS. It uses simple VHF radio to create this digital network where every ship is constantly broadcasting its name, position, course, and speed to every other ship nearby. It's like a real-time traffic map for the ocean.
But hold on, Skipper. This is where we have to pump the brakes. All this amazing connectivity, this constant flow of data in and out, opens up a huge and frankly terrifying new risk. As a satellite company Inmarsat says here, the shipping industry went from paper and pencils to fully digital practically overnight. And this rapid change has left it wide open to a new kind of pirate, the cyber attacker. If your system can receive data, a hacker can feed it false data. They could trick your GPS into thinking you're miles from where you actually are. They could shut down your engines. Cybersecurity isn't a feature you can add on later. It has to be baked into the design from the very beginning.
And that very serious warning about cyber attacks, Captain, is the perfect bridge to our third and final pillar, safety and regulatory constraints. Because none of this incredible technology exists in a bubble. It's all governed by this dense, sometimes confusing, but absolutely vital framework of international laws and performance standards. And every single one of them was written with one thing in mind: preventing disasters and saving lives at sea.
And if you're new to the industry, it really can feel like you're drowning in an alphabet soup of acronyms. You're looking at just a few of the big players here. You've got the IMO, which is a UN agency that basically sets the global rules for maritime safety. You've got the IHO, which makes sure a nautical chart made in Japan uses the same symbols and standards as one made in Germany. The IEC sets the technical standards for the equipment itself, making sure it won't fry in a lightning storm. And it all falls under the giant umbrella of the SOLAS Treaty, the safety of life at sea. If you want to sell a piece of navigation gear for a big ship, it has to be type approved, meaning it's been through hell and back in testing to prove it meets all of these different standards.
And these rules have a direct impact on the technology we specify. A perfect example is the electronic charts themselves. You've basically got two flavors. On the right, raster charts. Think of these as just a digital photograph of a paper chart. It's a dumb image. But on the left, you have vector charts, or ENCs. These are completely different. They're intelligent databases. Every single line, number, and symbol on that chart is a smart object. This is why official ENCs are the only charts you're legally allowed to use for primary navigation with an ECDIS. Because the system can actually ask the chart questions, like, "Hey chart, is there any water shallower than 30 feet along this route?" A simple picture can't answer that.
You are listening to OOTOT TV with research by author Paul Bulow.
And that brings us to our final section, where the blueprint finally becomes reality. This is the payoff. This is where all three of those pillars we've been talking about, what the mariner needs, the technology that powers it, and the strict rules that govern it, all come together on the bridge of a modern vessel. This right here is the nerve center. This isn't just a bunch of different gadgets bolted to a dashboard anymore. A modern integrated bridge is one single thinking system. It's where information from dozens of different sensors is gathered, analyzed, and then presented to the navigator in a way that gives them a complete, clear, and instant understanding of their world. All those abstract lines of text in our requirements document have been turned into this physical, working reality, a reality that mariners literally bet their lives on every single day.
So what are the key players in this integrated system? Well, you've got all the components we've talked about. The ECDIs is the brain, the radar is the eyes, you've got your gyro compass, your autopilot, your speed log, your radios. But the real genius is how they all talk to each other. The big challenge is avoiding what we call information overload. That's where something like the conning display comes in. It's like a master dashboard that pulls the most critical piece of information from every system, your heading, your speed, your rudder angle, your engine RPM, and puts it all in one clean, simple display. It takes a world of complexity and makes it manageable, especially under pressure.
And this is so important to remember. The requirement specification we've just talked about building, it isn't some document you write once, file away in a drawer, and then forget about. The requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation are updated and evaluated on an ongoing basis to incorporate needs and desires for new features and benefits, and changes to existing regulations and requirements for marine travel. It absolutely has to be a living blueprint. Technology changes, mariners discover new ways of working, and the rules are always evolving. That specification has to keep pace with all of it.
And that constant evolution, Skipper, that endless push for a more perfect system, brings us to one last and I think very important question. As our blueprints become more perfect, as our systems become more automated, more reliable, seemingly foolproof, are we forgetting how to build by hand? As our dependency on these incredible digital tools grows, are we losing the fundamental skills of seamanship? Are we forgetting how to find our way with nothing more than a paper chart, a pair of dividers, and the stars for that one day when all the screens go dark? It's a really critical question about the balance between human skill and our trust in technology, and it's something the entire maritime world is wrestling with right now.